Hello everybody. Welcome to the YouTube channel of Department of Physics, Veer Bahadur Singh, Purvanchal University, Jaunpur. So today we are going to perform an exciting experiment of electronics, that is microprocessor 8085. We are going to verify basic instruction of microprocessor 8085, hexadecimal addition of two numbers, and we will see how can we write data in ascending and descending order, and we will see many more things. But before we begin to perform this exciting thing, we should know what microprocessor 8085 really is. Because without knowing your enemy, you cannot fight with it. Don't worry, microprocessor 8085 is not your enemy, but it is important to know about your device before working on it, like how it works, so you can easily understand the working of our experiment. So, firstly, I am going to give you an overview of microprocessor 8085. Although there are many things to know about microprocessor 8085, but I will try to cover those aspects which are going to be used in our experiment. So you won't be surprised how it is happening. And if you want to study more about microprocessor 8085, then you can read Ramesh Gonkar's book. It will help you. Now let's coming back to our question. What is microprocessor? So in simple term, a microprocessor is the brain of the computer. It is a programmable electronic device that performs calculation, logical decision, control the entire system. The microprocessor works on three basic steps. Those are fetch, decode, execute. The microprocessor fetch the instruction from memory, decode the instruction, and execute the instruction. We can say that without a microprocessor, a computer cannot process data or give output, just like a human body cannot function without a brain. The 8085 is widely used 8-bit microprocessor. It consists of 16-bit address bus that can access 64 KB memory. It has 8-bit data bus. It works on single plus 5-volt power supply. It has built-in clock generator. It supports hardware interrupts and it uses hexadecimal addressing for programming. What is hexadecimal addressing? We will talk about it later. Just like humans evolved over time and became more faster and more intelligent, microprocessor also evolved step by step. The 8085 microprocessor belonged to second generation. It was discovered in 1976. At that time, it was mainly used in microcomputer, where only small processing tasks were performed. This stage was the beginning of modern computing. And later, the microprocessor became known as CPU, Central Processing Unit. So here is one question arises. Why we are studying 8085 even today? In our modern world, there are a lot of more advanced microprocessor available like Pentium. So why we are studying these microprocessor? So the answer to this question is it has a simple architecture. It helps us clearly understand registers, flag, buses and instruction cycle. It builds a strong foundation for advanced processor and microcontrollers. It explains how a processor works internally, not just externally. So, by studying 8085, we are actually learning the base of all modern processor. Now, let's talk about main parts of microprocessor. So, a microprocessor consists of ALU, register, control unit, system bus, and memory. We will talk about each one by one. So, let us start with ALU. ALU stands for Arithmetic Logic Unit. This is where all calculation take place. It performs arithmetic operation like addition and subtraction, logical operation like AND or XOR. The result is stored in register if we need it again and in memory if it is not required immediately. Now let's talk about the next part, that is registers. So Registers are small and fast memory locations inside the microprocessor. They store temporary data during execution. So there are many types of register. In general purpose register, there is A, B, C, D, E, H, and L. These registers can also pair up as B, C, D, E, H, L, and the HL is also denotes the memory. So this is the important register, and the accumulator A is also very important because it gives most of the result and store the result. Uh, if we add two registers, then the register can carry 16-bit address. And for example, if you have two register H and L, then the H denote the higher address byte and the L denote the lower address byte. We have temporary register. In temporary register, there is two kind of register: temporary data register, W and Z register. Then we have special purpose register. So in special purpose register, accumulator also included, flag registers and instruction registers. And then we have 16-bit register. So in 16-bit register, we have program counter, that is also known as PC, and stack pointer, that is known as SP. We will talk about this soon. In these kind of registers, the general purpose register and 16-bit registers are most important. So let us talk about program counter. The program counter is a 16-bit register. It stores the address of next instruction. After fetching an instruction, PC is automatically incremented. It controls the sequence of program execution. The stack pointer is also a 16-bit register. It points the top of the stack. Stack is a special area of memory used for function calls, temporary data storage, saving return address. Now let's talk about flag registers. So 8085 has 5 flags which indicate the condition of result. The first flag is 0. It will be set if the result is 0. The second one is carry, that is denoted with CY. It will be set if carry or borrow occurs. Third one is sign, that is represented with S. It represents the most significant bit. If MSB is 1, then it will be set. The next one is parity. It will be set for even numbers of ones. The next one is auxiliary, that is represented by AC. It carry from D3 to D4. Flags help the microprocessor take decision after operations. Now let's talk about the next part of our microprocessor, that is control unit. The control unit controls all the operation of microprocessor. It generates timing signals, controls data flow between microprocessor, memory, and input-output devices. It works like a manager, coordinating everything. The next part is memory. So, memory stores data and instruction. For example, in mathematics, if we do 13 plus 7, then the 13 and 7 are going to be our data, and the plus symbol is going to be our instruction. Now we have system bus. The system bus is a communication path. It consists of address bus to select the memory location and data bus to transfer the data. It works like a road that allows data to travel from one place to another. Now let us understand what language our microprocessor understands. So, just like in India, we have different languages. The microprocessor also have their own language. The microprocessor does not understand our normal language. It understands only binary language, which consists of 0 and 1. Just like in digital electronics, logic 1 means high voltage and logic 0 means low voltage. So, whatever data we give to our microprocessor, whether it is a number, character, or instruction, it will finally be converted into binary. But you will see that I will feed the hexadecimal numbers in my microprocessor. So, you are going to be amazed why I am doing this. If the microprocessor only understands binary, then why we are using hexadecimal? So, the answer is Binary number is not very convenient, it's very critical. So it is for human convenience. Human can easily understand hexadecimal numbers. So we are using hexadecimal number. Binary numbers are very long and difficult to read and remember. For example, if we take 13, then the binary number for 1 is going to be 0001, and for 3 is going to be 0011, and each character is of 4 bits, and when two characters are added together, they make 8 bits, and that will make 1 byte. So internally, the microprocessor only work with binary, but we use hexadecimal to write program easily and avoid mistake and understand memory address clearly. That's why in 8085 instruction, we mostly use hexadecimal numbers. Before instruction, we must understand the number system. We mainly use decimal number system that we are using from our childhood, that is 0 to 9, because it consists of 10 numbers. That's why it is called the decimal. The second one is binary number, which I have told you, that is 0 and 1. And the third one is hexadecimal number, that is decimal number like 0 to 9. But when it counts above 9 like 10 to 15, then it counts like A, B, C, D, E, F. Now let's talk about instruction set. So the first one is data transfer instruction. It is used to copy data, not to modify it. So in this instruction are like MOV, MVI, LDA and STA. So if we talk about MOV, it copy data between register or memory. For example, MOV A, B. The MVI loads immediate data. For example, MVI A 23H. Then the 23H is going to be in A. When you will check the register A, you will find that the value of register A is 23H. The next one is LDA, load accumulator directly from memory. For example, LDA C000H. This loads the address directly. The second one is STA, store accumulator into memory. And the next instruction is arithmetic instruction. It is used for calculation. Normally in our mathematics, the add one, the ADC and the sub, and there are many more, but we are trying to look on those things that we are going to use in our experiment, so that you can easily understand everything. Although the microprocessor 8085 has many more things to discover. Arithmetic instruction used for calculation. Add is for add data to accumulator, ADC to add data with carry, and sub means subtract data from accumulator. This instruction affect flags. The third one is logical instruction. It is used for logical decision like ANA means for AND operation, ORA means for OR operation, XRA means for XOR operation. It is used in masking and comparison. The next instruction is branch instruction, and we can say it jump instruction. It is used to change the flow of the program. In this JMP, that is for unconditional jump, JNZ, that is for jump if zero flag is not set, JC, jump if carry flag is set, and JNC, jump if carry flag is not set. And RST, it is for restart instruction. It is used in loops and condition. And the next thing is increment and decrement instruction. It is used for counting, like INR is for increment by 1, DCR is for decrement by 1, INX is for increment register pair, DCAX is for decrement register pair. Now we have rotate instruction. It is used for a bit manipulation. RLC is for rotate left, RL is for rotate left through carry, and HLT instruction. The HLT stop program execution until reset or interrupt. But you will see that in our microprocessor, we will use CF and EF. With the help of those, we are going to stop our program. So now we will talk about the components that are presented on our microprocessor 8085. This is our advanced 8085 microprocessor trainer kit, and it consists of power button. Let me on the power button. So now it is on and you can see that this microprocessor consists of inboard power supply as well as onboard power supply. As you can see that 5-volt ground plus 12 volt and minus 12 volt to perform external operation like ADC, DAC and many more things. And this microprocessor consists of 8085 microprocessor CPU, the central brain of the board. It execute program and control everything. It has 8-bit processor. And this is our memory section. So this section consists of EPROM and RAM. EPROM stores the monitor program, help to enter data, view memory and execute program. And RAM is used for temporary memory for user program and data. So it is up to 8 to 16K and it can expanded up to 64K. And as you can see these lines that are going here and there, so these lines act as buses. So with the help of these lines the data flow everywhere. And this is our LCD display. So whatever program we will run, it will appear here. And this is our 16-bit timer and counter IC. As you can see that here it is mentioned, this is our timer and counter IC. And this is our IO interface. It is also called as programmable peripheral interface, and it is two in counts, that is 82551 and 82552. It consists of 24 IO lines. And these are our FRC connectors. So FRC means flat ribbon cable connectors. So it is used to connect external peripherals modules. And here is our serial interface. It is RS232 connector. It connects via SID or SOD lines. And here is our reset button. When you will write the program, if anything you write that you didn't want, press this button. So when you will press this button, you will come back to the starting points. And this is our keyboard connector cable. I mean, with the help of this cable, we have connected our keyboard. With the help of this keyboard, we will write the instruction and the program, and that will go to this microprocessor, and we will see our result here. So this was all about the system description of 8085 microprocessor trainer. Now we are prepared to perform our experiment because we have already understand the terms that we are going to use in our experiment. The first thing that we are going to perform is to verify the basic instruction of microprocessor 8085, and these instructions are data transfer instruction, logic instruction, arithmetic instruction and branch or jump instruction. So we are going to perform each instruction one by one. Let us start with data transfer instruction. I have already written the program for data transfer instruction, and I am going to show you the program. Okay, so I think you are able to see it properly, that this is our program and this is the program for data transfer group. So with the help of this, we are going to check like if our data is transferred or not. So here you can see that this is address, this is hex code and this is instruction, or we call it mnemonics. This is for us like to understand how the things are working. So these are the things that we are going to provide our microprocessor, and then we will get the result. So now let us see how it will work. But before that, let me tell you the meaning of these. So the first thing is that when we will write this hex code for 2000 address, then what instruction we are giving? We are saying that it should load 30h into register h. And then what we are doing here, we are providing the immediate value for h, that is 30. And then again we are saying it to do load 40h into register l. And what we are doing here, we are providing the value for l, and here we are storing the CA value at memory location pointed by HL, and then again we are providing immediate value for memory, that is CA, and this is RST. So RST is for return to monitor program, and with the help of CF we are going to do that. Okay, so this was all about how the program is going to execute. Okay, so now let us start. So let me on my microprocessor from here. Okay, so what I am going to do, what I have showed you in the notebook, I am going to put the data here. First of all, you have to press M, then the first address, that is 2000, and then you have to press enter, and then you can see that here is already some code, so don't worry, we have to do nothing with that. This is the code for previous operation, we have to feed our own code. For 2000 we have 26, let us write 26. Okay, now press enter. This will show the next step that should happen, and that is 2001. So what we have for 2001, we have 30. Now type 30, then enter. Then for 2002 we have 2e, so type 2e, then enter. Then for 2003 we have 40, then enter. Then for 2004 we have 36. Okay, then enter. Then we have 2005 CA, so let's enter CA, and then for 2006 we have CF. Now we have written our program. What you have to do next, you have to save it, and to save it you have to press dot. Here is dot, you have to press this. So I am pressing this dot, and now your program is saved. As you can see that we have returned back to our main menu, and now to we can say that to execute this, what you have to do, you have to press G, you have to press G. So now I have pressed G. Then what I have to do, I have to type first address, that was 2000. So 2000, and then I have to like save it with the dot. Okay, now how would I check that did I get the value what I wanted or not? So to do that, I have to type R. I want the value of H, or I want 30 value on H. So now I am going to type H. We got our H value, and then I will press enter. We got L value. The memory value will have M, then H and L, so 30 40. And what we commanded to memory, that the memory should store CA. So let's see if the memory stores CA or not. Now let's get back from here. So we can, here I have already told you that here is reset button. Let me press this. Now we have returned back to our menu, and we have to type M, then we have to type 3 and 4 and 0, and then enter. So I hope we will get CA. So yeah, as you can see that CA, and that was the command that we have given to our microprocessor, that is CA. So we got MVI CA, and for L it's 40 and for H is 30. And if you want to see here, this is the thing that I have performed, and this is our result. H equal to 30, L equal to 40, and M 30 40 equal to CA. So we have successfully completed our first data instruction, that was MVI, move immediate, and the next instruction for data transfer instruction is STA, store accumulator direct. So here is the program. As you can see that the process is going to be same. Here we are saying that load ATH into accumulator A. So we are saying that it should feed ATH in our A register, and then here we are providing the actual value that should be loaded, and here we are saying that STA 2050H. So here what we are doing, we are providing it a memory location, and that is 2050, and we are saying that store A into memory location 2050H, And then I have already mentioned you that if we have two register like H and L, then the H is going to be higher address bit and the L is going to be lower address bit. So as you can see that here the memory location is 2050, so it's H and it's L. Now we are going to perform this, and we will end our program with CF. And in the next video we are going to perform this instruction in our microprocessor, and we will see that if we are getting the value of M2050 is 80 or not. So thank you for watching.